Hello, everybody. My name is Cristian Cretu. I work for HC Starck in Newton, Massachusetts. I've been here for about 12 years. It's a beautiful suburb of Boston in the United States. Thank you, everybody, for taking the time to join us. It's a little bit bizarre. I gave many presentations in my life, but this is the only one where I feel like I'm talking to myself. I can't really see anybody. I can't really see any feedback. So I can only hope, fingers crossed, that everybody can see and hear well. Well, this being said, I'm going to go. We only have a half an hour. Just wanted to say that I wanted to thank a variety of my colleagues that arranged this, and my colleague, Mr. Robert Marciando, that is a co-speaker here today. He helped me a lot in assembling the information. And he's here primarily to give me much needed technical support. As you will see in the conversation later, he's got a lot more experience than I do. So this being said, the topic of today's talk is molybdenum in glass melting, products, applications, and benefits. And we wanted from the very beginning to cover a much broader category of products, sometimes forgotten. Molybdenum, for us, it's extremely important. It's a very big business. Approximately 500 metric tons of molybdenum glass melting electrodes and other products are sold globally every year, if not more. But perhaps for the people making glass, it's really not necessarily the focus anymore. However, as you will see, there's a lot of interesting things to be known, primarily about molybdenum glass melting electrodes. So without further ado, let's go, because this is going to be the focus of this application. We'll list some others, but we'll talk mostly about GMEs, or glass melting electrodes. So we'll start with a quick overview about HC Starck, just a regular introduction so that we know about each other a little bit. And then we're going to go to the topic and discuss why molybdenum. It is the material of choice, glass electrodes, types and benefits, a little bit about how to actually use the electrode once one get it, and then some closing remarks, questions, and answers. I don't want to spend too much time, but I think I want to let everybody know HC Starck has been around for 100 years. In fact, this year we celebrate our 100 years of existence. It is a very interesting company with a lot of experience, primarily in refractory metals, molybdenum, tungsten, tantalum, and niobium. We are either number one in the world in our materials, or we're a very strong follower. We have a global reach. We've been serving these markets for many years, as you'll see in the next slide. We are proud that we work with our customers to provide a lot of innovation and employ our experience and creativity to develop new products all the time, following the mega trends. Glass is part of these mega trends. We all have these amazing devices, all the phone, all the tablets, all these smart watches, they all have glass components. And the so-called smart glass also includes layers that you may or may not know are actually metal or metal oxides, and some of them are based on molybdenum, which is also made by HC Starck as sputtering targets. Now, just a few words, right? You see here a timeline that basically shows that we started in 1920 in Germany. We are a German company by Hermann Karl Starck. Without going into every detail, I think why this is important is that in around 1945, we not only were operating in molybdenum, but at this time, we actually implemented a significant expansion and modernization of our reduction capacities. So our knowledge of purifying and making high quality molybdenum is quite solid. The company grew. There was a group, grew to about $1 billion in sales and about 3,000 people employed. More recently, it was acquired from Bayer by a group of financial companies, Advent and Carlyle, and it was sold. And what we call ourselves HC Starck Solutions, we are the natural hair of this group. Right now, we have approximately 600 to 650 employees in our 5 manufacturing capabilities around the world and sales offices. And you can see here the location. 3 of them are in the United States. 1 is in England, 1 in Germany near Leipzig, and one in China near Shanghai. Molybdenum is manufactured primarily in Michigan. We manufacture from we buy material from the mine and purify there, reduce. We have arc melting. We can manufacture final product there, but also we supply for a number of global customers out of our Hermsdorf capacity. Hermsdorf utilizes cold water made molybdenum, which is then finished and sold worldwide. Our capacity in Karl is also able to supply a smaller scale, and it's also an active part in realization of the coated electrodes. Without spending too much time on this slide, this basically describes our 4 materials of focus: moly, niobium, tantalum, and tungsten, that are basically transformed in a wide variety of semi-finished or finished parts, fabrications, assemblies, and we also offer services. Glass melting electrodes is a part of this. It's a very significant part. In fact, the cold water reduction facility is probably one of the largest, if not the largest in the world. It's quite impressive to visit, and it's one of the backbone of that particular facility. So let's talk about molybdenum. Why molybdenum? What products? How should we use them? How should we choose them? We'll take a few slides to discuss this, and perhaps at the end we'll have a few time for questions and answers. So what are the products, right? So, you know, in a variety of glass melting furnaces, you need a variety of parts. You know, you of course need electrodes that we mentioned already, but not only. You need stirrers, you need mixers, you need reinforcements, you need all kinds of melting cones, flow orifices, wear parts. It's quite a wide variety, and it's hard to talk about. But one common element to all these is molybdenum. So in this picture, we try to show, you know, a couple of parts that we make. Of course, there's a lot of sheet, plate, and other assemblies, but it would be overwhelming to go over all of them. So we decided, why don't we try to focus on the GMEs, which are probably the most important and critical part. So why molybdenum for all these parts? And if one thinks about it, molybdenum is not necessarily the cheapest one, right? But it has a very interesting combination of properties. Primarily, right, it has a very high melting point, 2,630 degrees Celsius. It has exceptional stability in molten glass. It does consume, the electrodes are consumable after all, but it's one of the best choices in metal electrodes. And as time has proven, it is the preferred choice. It has very good thermal and electrical conductivity, low CTE, good corrosion and erosion resistance, very high strength in high temperature molten glass. It also has fairly good machinability, which is significant when you want to generate fine threads without defects, and also a high quality surface. And of course, it's been used in so many different types of glasses, so it's a common denominator. It works in a wide variety of glass types. What does this mean to the user? Well, higher energy efficiency, a lot of flexibility, especially in boosting electrically. It lowers the capital cost and cost of ownership. It gives more control over operations and flexibility in meeting the environmental needs of a company, especially these days around the world. Everybody is trying to reduce NOxes and emissions. Of course, it goes without saying that it generates less dependence on traditional or radiant heating, and used properly, it can have a significant impact in lowering the maintenance costs when compared to alternative heat sources. So now that we understand why molybdenum was chosen and continues to be the material of choice, we thought, well, what type of glass melting electrodes are out there? You know, you'll see a variety of suppliers offering a variety of different types. If you look at them, they all look fairly easy. It's a rod. It's a metallic rod with probably a hole on one end and a thread on the other end. It's not as easy as that. You'll see here 4 different groups. The first one, and I would say the overwhelming majority of electrodes are in this group, it's powder metallurgy based GMEs. It is definitely the most common. It's proven, everybody likes it. It's almost a commodity. It does have problems. As you can see, if you don't use the right type, you can end up with all kinds of bubbles or impurities. You know, when you deal with powders, you will always, powders and voids go hand in hand. Minimization of voids in this process of powder metallurgy is critical, and we developed, with many years of experience, a variety of methods to minimize these, which we believe sets our GMEs apart and gives them additional value. We also make electron beam melted, or so-called molymelt EV glass melting electrodes. These are not so common. They are typically used only on premium glass. Why? Electron beam, it's basically a process in which one melts molybdenum by bombarding it with several, let's say, streams, if you want, of accelerated electrons. And they basically raise the temperature of the metal to such high melting points that pretty much all the other elements, with minor exceptions, will boil and evaporate. So this is not only a melting process, it's also a purification process. As a result, what you will get, first of all, is you'll get a fully solid, right? There will be no voids. The amount of impurities are in these greatly reduced, right? So the typical electrode is 99.95, and it has a certain chemistry, but in the process of electron beam melting, most contamination is eliminated or dramatically reduced, right? So this is a different type of electrode. It's typically more expensive because this is not a cheap process to implement, but it does generate extremely high quality product. Of course, molybdenum, although a strong metal, it does have certain challenges, and where you really need to have improved strength and corrosion resistance at high temperatures, we offer zirconium doped electrodes to the market, right? There's a process in which a certain amount of zirconia is added, and zirconia acts as a stabilizer and a strengthening element to the molybdenum electrode, generating a premium electrode that is desirable in certain applications, as explained a little earlier. And finally, the so-called coated electrodes. What happens is when you start the furnace, right, you will end up exposing molybdenum to some sort of environment or some sort of oxidation, typically air. And that's not good. Molybdenum, as you know, probably it generates a volatile oxide, and you don't want to get there because that will basically generate very rapid erosion. And this we'll discuss in a couple of slides a little bit later. But by coating with this ceramic layer, we give molybdenum sufficient, let's say, protection until it's actually fully immersed and now protected by the glass. The coating is exceptionally adhering. It's a chemical bond. It's a ceramic layer. Basically, being that it's a silica-based, it has little to no impact at all on the glass quality. So let's talk a little bit more in depth about these electrodes. How do you choose a good electrode? What is a good electrode, right? We already discussed a little bit about purity, about strength, about corrosion. But let's look at these things a little bit in more depth. And one thing that some people realized is the thread, right? It's important. Why is the thread important? It's because when you install these, you don't want your operators to be in those rather dangerous environments for too long. So all of a sudden, by changing the type of threading, you can accelerate the installation time. In our experience, as fast as 3 to 4 times by using a certain type of tapered electrode. This may not sound like amazing, and you may think, "Why is this important?" But it does speed up everything, and it does keep people away from dangerous environments. Dimensional factors, concentricity and straightness, both very important. Why? We'll discuss in a couple of slides about this a little bit more in depth, right? But it's not enough to only choose a good electrode with good dimensional control, both in concentricity, straightness, surface quality, thread quality, free of voids, free of impurities. It's also important how one uses. And you will see in a couple of slides later why this can be a problem in operation, and it can be a big problem. Right, low carbon, especially for specialty glass, is part of the purity, but these last 3 bullet points, the low carbon, controlled microstructure, and chemistry, are very important. It's all part of material science. For specialty glass, the low carbon is critical. The microstructure control has a dramatic impact on how well these electrodes resist the temperature and glass convection without sagging and with minimized creep. Right. And of course, purity, that goes without saying. And without spending too much time on this slide, which is rather complex, it's basically this slide that's trying to say that, look, you can't really achieve all these without proper control, literally from mine to selling the finished product, right? And the columns here, the green columns, are all processes that HC Starck has in-house. For example, if we look at the first one, which is a little bit gray, right? It indicates raw material coming from the mine, which is true. We purchase from the mine, we take it to Coldwater in Michigan for reduction, right? We also have a variety of other things available there, right, to make the electrodes. We have sintering, we have arc melting, we have electron beam melting in Germany, but many others. However, the process, without giving too many details, right, we have so many tools. We have rolling, we have extrusion, we have rotary forging, we have a variety of pickling, machining, and other tools at our disposal, all inside, all with extremely experienced personnel to make sure that that material that comes from the mine will be converted to a premium product that will give you, the consumer, the quality and lifetime that you need. So it's getting a little closer to the end. So sure, we understand why molybdenum. We understand what's important. Perhaps now we know, okay, maybe I should keep all these things in mind when I choose something. But now that you have it, what are you going to do with it? You can't just think that, hey, this is great, I'm going to install it, it's going to work, and push a button. That's what we want to achieve, but there are little tricks of the trade. And here in the next two slides, there's 6 of them, right? Effect of the electron holder on lifetime of the GME. Improper electrode adjustment in the holder can lead to a very rapid attack through diffusion of other elements from the holder into the molybdenum. These elements typically lower the melting point, render the material softer, hence it's not as resistant to creep, sagging, and convection of the glass. Contamination with foreign material. It's similar. You know, if contamination comes not from the holder, it could come from other areas, from outside. So when installing and using, extra care needs to be taken that the electrode remains clean and the equipment is properly cleaned and controlled so that any foreign contamination or edges or sharp corners that could scratch or damage the electrode or contaminate the electrode are eliminated. Degradation by air outside the furnace, you know, below 400 degrees Celsius, molybdenum is fine. When you go above that, things start to happen, and especially about 700 degrees Celsius, which is nothing for molten glass, you start forming molybdenum trioxide. It's a sublimation, so it goes from solid directly to gas, and you will see a very interesting smoke. And yeah, it is typically not a good thing to see this because your electrode is about to be destroyed. The other 3 effects are contamination from the actual glass, right? Glass has, you know, chemistry, right? It can contain a wide variety of elements, lead, nickel, chromium, antimony, and so on and so forth. They can negatively influence the lifetime of the GME, so this needs to be kept in mind, you know, as they do have an impact on the duration of the electrode. Current density, also very important. So one has to design for a current, electrical current density of somewhere around 10 amps per square inch. You can go a little higher. You can see here they can live as high as 20. But that will lead to 2 bad things: increased temperature at the surface of the electrode and increased convection in the glass, which both, one softens the glass, the other one erodes the glass. And after that, if you continue at this high current, you will have a cascading effect in which you have now less surface area, as it is less electrode surface area because it's eroded, generating you know, exposed to convection and higher current. So it will go down fairly fast from there. And finally, sagging and creep. All materials, you know, with perhaps the exception or very small, you know, in ceramics and whatnot, are subject, or let's say all metals, right, of creep. It's extremely small movement in the right conditions in time. Control of creep, we strive to produce microstructures that are finely tuned to protect the customer from this, but it's also operational control. So it's a dual factor situation. So you have to avoid super high temperatures. In short, proper understanding of factors that negatively impact the electrode lifetime can have a significant impact, a positive impact on the duration of a GME, and therefore the correct operation and the total cost of ownership of the furnace. So in closing remarks here, I just wanted to say that we continue to believe that molybdenum is and will probably be for a long time a key contributor to glass melting. And we will continue to make good quality electrodes as we expect that with efforts to eliminate plastics, we'll see more and more glass also used in other applications, not only elimination of plastics, right? We think that while we try to provide the absolute best that is out there, it's also important for the user to understand how to choose and how to use the electrodes in order to have full benefit from the quality that they're purchasing. And finally, but maybe the most important, let's not forget that we live in this so delicate surface of this so delicate planet, as we now learn with COVID. Who would have thought a year ago that we'll all wear masks? It's almost like the scenario of a horror movie. We always try to recycle, to build sustainable processes for the future, so the kids and the kids of our kids will be happy and healthy. So thank you very much. I really appreciate this, and thank you, Bob, for helping me with the content. Please, if you have any questions, let me know, and we will try to answer the best we can. I might ask Bob to help with some of the more technical questions. Thank you very much. So far, I don't see any question. Well, all right. A question from anonymous attendee. What is the quality, health, safety impact from fume volatile molybdenum trioxide above 700 degrees Celsius? It happened during melter drainage. So I don't know how this works. I'm going to give you my best shot. So I'm going to repeat the question, right? What is the quality and health and safety impact from the volatile fumes of molybdenum trioxide above 700 degrees Celsius happened during melter drainage? We deal with this fume a lot in our factory in Coldwater. It's part of our daily life. To be very, very honest, I don't know. I'll be very happy if you contact me to give you all the information from our technical people in charge. As far as I know, it's okay, but don't take my word for this. I can give you documentation and data, but for us, it's not a problem. Bob, do you know?
We deal with it on a regular basis. So to answer the person's question, we will consult with our EH&S. We do have special areas that are dedicated where in the process of making our products out of molybdenum, oxidation is an everyday occurrence. It's confined to a specific area of our fabrication and manufacturing processes, and we will pass along any special precautions that we take in consideration of the oxidation that occurs at higher temperatures.
Thank you, Bob. We have another question. So we have another question from Mr. Roland Heydrich. He did not see our facility in Goslar in Germany. It is true, because we are no longer a part of the HE Starck Group. HE Starck Group was sold in the past 2 years to a variety of companies. Our Goslar facilities were not part of the HE Starck Solutions anymore. We consider it our sister division, but we are now different companies. So we have another one about the ceramic coating. Yes, we offer this from our facility in Caen in the UK. Well, the webinar is ending, so thank you everybody, and thank you, Bob. I hope this was informative. Thanks everybody. Stay safe.
And thank you all for your attention today. Thank you.